welcome to my channel, and please like, subscribe, and share. So, in this video, we're going to talk about Mars, the fourth planet from the sun. I skipped Earth because it's where we live on. So, Mars is also known as the red planet. It's because it's normally made of iron oxide, or if you don't want it, it's scientific. Just call it rust. Okay, so more on the facts in the video. So I'm moving to SpaceEngine. So bye. Okay, so in this video we're going to talk about Mars, which is the fourth planet from the sun. So here we are at Mars in SpaceEngine. First, we're going to Mars formed because before when Jupiter existed and was still in the early stage of life, Mars didn't exist. But Jupiter had nothing to do with Mars. Right? So it happened because as the sun was still just a protostar or T-Tauri. So when it was a T-Tauri star, it actually had an accretion disk. If you don't know what an accretion disk is, it'll be coming in my upcoming videos. But it's accretion disk, but it had an accretion disk, and then Jupiter got most of the accretion disk. Jupiter kind of got most of the accretion disk and became a gas giant, and the accretion disk and the accretion disk and the sun also took most of it. But in the remaining of the accretion disk, it formed the terrestrial planets such as Mercury, Venus, Earth, and Mars. So it had nothing to do with the big gas giant, Jupiter. So a thing that why Mars is why it is very rocky. So Mars is rocky because the meteoroids, but let's talk about why there are craters first. If you see all these things, just as I explained, it's the same as the Mercury video. All these are still craters. Mars had the second largest amount of craters in the whole system, but I didn't tell you how craters are formed yet. So when meteoroids, which eventually get transferred into meteors, get into Mars' atmosphere, most of them just burn up in Earth's atmosphere. But in Mars' atmosphere is so thin, where the meteoroids can easily get passed through, become meteor, and they don't pass the intermediate meteor state. So they just become a meteorite, and so that's about it. Then talk about the composition of Mars. First, it's carbon dioxide. Let's just not go. So Mars is made of some carbon dioxide. Not some carbon dioxide, a lot of carbon dioxide. But about 95% of Mars is carbon dioxide. There's also argon and even some water, but less than about 0.001%. of water on the surface. So next has less It also has oxygen, which usually is used for it. But when you're breathing outside, you might think that you're made of carbon dioxide, so you might think that you're breathing carbon dioxide, but that's just wrong. Sometimes we don't breathe carbon dioxide, and we breathe oxygen. But because of this planet's low oxygen amount, which is about 0.01%, it isn't exactly suitable for human life, and it'll only be suitable in the future. So, and also water is way less, but I already told you. And there's also methane or methane, if you like to call it that. And there's a lot more. And also 1 year is 2 Earth years. If you don't know why, let's look at its orbit. Let's kind of just zoom out. Let's just kind of zoom out enough to see this planet's orbit. So as you can see, this is Mars's orbit. So this is Earth. This is Earth. So as you can see, Earth is farther away than Mars. But we aren't able to calculate the real number of like years it takes. If you don't know why, I see how it gets smaller. The orbit gets smaller here. This dot right here is called the pericenter. But it gets farther here. This dot here is the epicenter. And the circle represents language points. We'll talk about those later. But next we're going to do so. Also, because of this eccentricity, here it's something like 1 year right there. But way over there, it's something like 3 years. So we don't really know the correct answer, but yeah. But it can also be way bigger. It can also be way bigger. It doesn't exactly take that much. Let's kind of just zoom in. And Mars' orbit is actually pretty slow. This is the max amount, but let's not talking about that right now. And did you know that there can also be water on Mars? Let's go back to the real Mars and turn off the orbits. So, there's an image called blueberries on Mars. They're not really real blueberries, but they're nicknamed blueberries. And some people even think that blueberries on Mars could be a sign of life and even water. So how can blueberries how do we think those blueberries can have water? Earth is the reason that blueberries are actually, because some of the formations, such as the blueberries and some other formations that we don't really know about yet, could be signs of life and water in the past. So next why we want to colonize Mars. So, people just are like really greedy. They just want to colonize Mars and everything. Colonizing Mars is taking a lot of money, but let's not talk about humans right now. So, why people want to colonize Mars is just because they think that then about the polar ice caps. The polar ice caps are way colder than Earth's ice caps. Let's go up and up and up and up and up. So let's look at the polar ice caps. Okay, so I'm going to show you the polar ice caps. You can't see the polar ice caps right now. I'm going to show you. Okay, so that is it. So, you can't see the North Polar ice caps because they're just not here. Let's look at the South Polar ice cap. So the South Polar ice cap is very small, but why it's very small here is because in summer it is smaller than in winter. Everybody knows that it happens on Earth, but it's just less effective on Mars. It's just less effective on Mars. So there's also volcanoes, and we're also going to talk about texture. So we're going to talk about texture at the end. So